we're going to graph the angles between each of these three vectors after we draw them in standard position. So the first angle, W1, you start at the origin, and it is 2 to the right and 3 up. 1, 2, 3. So it's here. And then we'll do this one in green. It's 4 to the left. 1, 2, 3, 4, and 1 up. So we'll go here. So W2 is green. W1 is purple. And we'll make W3 blue. And it goes over 1 and down 3. 1, 2, 3. So over 1, 1, 2, 3 here. So those are our angles. Now, all of them, you can find the angle with respect to the x-axis by just saying, let's do it this way. So the angle with the x-axis, we'll call it theta, is the tangent inverse of the y-coordinate over the x-coordinate. Okay, it's the tangent inverse. And so we could do that. So from the x-axis to this one is the tangent inverse of 3 over 2. And that turns out to be 56.3 degrees. But that's not really what they asked for. Okay, we could also find this angle to the green one by doing the tangent inverse of 1 over -4. Now, the tangent inverse gives us -14 degrees, because tangent inverse can only give you angles in here. But instead of this -14, we want to add 180 to it and get that angle. So this is 165.96. Now, what they wanted, though, was the angle between these. So if I go 165.96 and subtract off the 56.3, I find that this angle between here, between these, is 109.66. Okay. Then, if for the blue one, we do the tangent inverse of -3 over 1, we find that this angle is -71.6 degrees. But remember, they never asked us, and if we would do it in the positive direction, so if we add 360 to that, so we can compare apples to apples, this is the same thing as 288.4 degrees. Now we can find the angle in between these. So from 288.4, from the blue one to the green one, is 288.4 minus the 165.96. 0.96. Okay, so we're going 288.4 minus 165.96. So from this back to here, this is 122.4. And then the distance between these, the angle between these is 56.3 minus this negative 71.6. And this angle in here, this is 127.9 degrees. Now, we could have done any of these with a different formula. Okay, there's a formula that says the cosine of the angle between these is the dot product. So say W1 dot W2 over their magnitudes multiplied. Now, is that more work? Maybe, maybe not, but let's just do it with one of them. Okay, let's just do it with, here's W1 and W2. So if we do the dot product, we do x with x is minus 8 plus y with y3. So this gives us negative 5 over. The magnitude here is 4 plus 9. This is the square root of 13. And the magnitude of 2 is 16 plus 1. This is the square root of 17. So this ends up being the square root of 13 times 17. 221. And I'm pretty sure, is that 11? No, it's not. 121 is 11. Okay, so that's not the angle. That's the cosine of the angle. So if we would do the cosine inverse of negative 5 over the square root of 221, we should get this 109.66 because that's the formula for it if you don't want to find each angle individually. So if I go negative 5 divided by that square root, and then I do the cosine inverse, I get 109.65. So little rounding error, but we get pretty much the same thing. Now, add all three angles and explain why the sum makes sense. Well, what would you expect if you added all these angles? My guess is that they should add up to 360 because that's the number of degrees around a whole circle. So let's try it. Let's take 109.66 plus 122.4 plus 127, was that 0.9? And see what we get. And turns out that when I add these, I get 359.96, which with rounding error is pretty close to 360 degrees. And it makes sense because that's the number of degrees when you make one full rotation around a circle.